Climatology Part April 4, 2015. 4. Atmospheric pressure belts and wind circulation. The air, that is a mixture of several gases, exerts pressure through its weight. Their pressure or atmospheric pressure is defined as total weight of a mass of column of air above per unit area at sea level. 1. Distribution of atmospheric pressure. Vertical distribution. The density of air and the atmospheric pressure is high at the lower layer of the atmosphere. The atmospheric pressure decreases with increasing height. Though there is no direct relation between the increasing height and the rate of decrease in atmospheric pressures, yet in the troposphere the rate of decrease in air pressure is 34 megabytes for every 300 meters of height. Horizontal distribution and pressure belt sky. Equatorial low pressure belt 10 degrees then 10 degrees. Yes, this is a belt of very low atmospheric pressure. The equatorial low pressure belt is thermally induced because the ground surface is intensely heated during the day due to almost vertical sun rays, and thus the lowermost layers of air coming in contact with the heated land also gets warmed. In this zone, there is almost no horizontal movement of air. The air in this belt rises up. This belt represents the zone of convergence of NE and SE trade winds. Because of frequent calm conditions, this belt is called a belt of calm or doldrums. II. Subtropical high pressure belt 231/2 of a degree, 35 degrees in both the hemispheres. This belt owes its origin to the rotation of the Earth and sinking and settling down of winds. It is, thus, mainly dynamically induced. The air rising at the equatorial belt starts blowing forward. But these winds get deflected towards east due to rotation of the Earth. This phenomenon was first discovered by the French scientist Coriolis, hence this force exerted by the rotation of the Earth is called Coriolis force. The quantity of the force keeps increasing with increasing distances from the equatorial belt. This zone of high pressure is called horse latitude because of prevalence of frequent calms. In ancient times, the merchants carrying horses in their ships had to throw out some of the horses while passing through this zone of calm in order to lighten their ships. This is why this zone is called horse latitude. II. Subsolar low pressure belt 45 degrees, 661/2 of a degree in the hemispheres. This belt is also dynamically induced. In fact, the surface wind speeds outward from this zone due to rotation of the Earth, and low pressure is caused. In this zone, the air coming from the subtropical and polar high pressure zones converge and rise up, creating a zone of low pressure. This zone is characterized by cyclonic storms. IV. Polar high pressure belt near the north and the south poles. High pressure persists as the poles throughout the year because of prevalence of very low temperature all the year. The air subsides in this zone due to intensive cooling and results into high density. Farrell's law of deflection. Within this pattern of permanent pressure belts on the globe, winds tend to blow from the high pressure belts to the low pressure belts as the planetary winds, instead of blowing directly from one pressure belt to another. However, the effect of the rotation of the Earth Coriolis force tends to deflect the direction of the winds. In the northern hemisphere, winds are deflected to their right, and in the southern hemisphere to their left. This is known as Farrell's law of deflection. The Coriolis force is absent along the equator but increased progressively towards the poles. For this reason, winds blowing out from the subtropical high pressure belt in the northern hemisphere towards the equatorial low become northeast trade winds, and those in the southern hemisphere become the southeast trade winds. 2. Wind circulation. The wind belts girdling the planet are organized into 3 cells: the Hadley cell, the Farrell cell, and the polar cell. Contrary to the impression given in the simplified diagram, the vast bulk of the vertical motion occurs in the Hadley cell. The explanations of the other 2 cells are complex. Note that there is one discrete Hadley cell that may split, shift, and merge in the complicated process over time. Low and high pressures on Earth's surface are balanced by opposite relative pressures in the upper troposphere. Hadley cell. It is the strongest of the 3 cells of circulation and is formed as warm air rises above the equator and starts to flow northward. The northward flow deflects to the right due to Coriolis, becoming an upper-level westerly flow. As this air moves northeastward toward the pole, it cools and a portion of it sinks at about 30 degrees N. This sinking air spreads northward and southward as it nears the surface. The southward moving air again deflects to the right, becoming the northeasterly trade winds. Because of the circulation in the Hadley cell, two pressure belts are created. The first is a belt of semi-permanent high pressure that results from the sinking air at 30 degrees. This belt of high pressure is called the subtropical ridge. The second pressure belt is a through of low pressure near the equator. It is called the near equatorial through. Polar cell. This is the northernmost cell of circulation, and its mean position is between 60 degrees N and the North Pole. At the pole, cold, dense air descends, causing an area of subsidence and high pressure. As the air sinks, it begins spreading southward. Since the Coriolis force is strongest at the poles, the southward moving air deflects sharply to the right. This wind regime is called the surface polar easterlies, although the upper winds are still predominantly from the southwest. Near 60 N, the southeasterly moving air moving along the surface collides with the weak, northwesterly surface flow that resulted from spreading air at 30 degrees N. This colliding air rises, creating a belt of low pressure near 60 degrees N. Figure 1 simplified global 3-cell upper air circulation patterns. Farrell cell. The mid-latitude circulation cell between the polar cell and the Hadley cell is called the Farrell cell. The Farrell cell circulation is not as easily explained as the Hadley and polar cells. Unlike the other two cells, where the upper and low level flows are reversed, a generally westerly flow dominates the Farrell cell at the surface and aloft. It is believed the cell is a forced phenomenon, induced by interaction between the other two cells. The stronger downward vertical motion and surface convergence at 30 degrees N coupled with surface convergence and net upward vertical motion at 60 degrees N induces the circulation of the Farrell cell. This net circulation pattern is greatly upset by the exchange of polar air moving southward and tropical air moving northward. This best explains why the mid-latitudes experience the widest range of weather types. The global circulation patterns the wind on Earth. Winds that blow predominantly from a single direction over a particular point on the Earth's surface are called prevailing winds. The general trends in wind direction are called dominant winds. Prevailing winds greatly influence climate patterns such as rainfall gradients, where the windward side of mountains have high rainfall while leeward side experience desert conditions. Wind rot is a graphic plotting tool that is used to describe the speed and direction of wind at a particular location. Insects drift along prevailing winds, while birds are able to fly independent of them in general. Regional winds can be divided into two groups: global winds like easterlies, westerlies, local winds like land breeze, sea breeze in general. Easterly winds flow at low and high altitudes, i.e. near the tropics and the poles. 8. The planetary or prevailing winds. 1. Trade winds. Trade winds are the prevailing easterly winds that blow across the tropics. They blow from the northeast in the northern hemisphere and from the southeast in the southern hemisphere. Trade winds act as the steering for tropical storms that form in the Atlantic, Pacific and South Indian Oceans. These storms make landfall in North America, Southeast Asia and India, respectively. Directly under the subtropical ridge, i.e. close to the equator, winds are lighter in intensity. These subtropical regions are called the doldrums, or horse latitudes. Most of the Earth's deserts are found near the subtropical ridge, with high pressure leading to low humidity. Trade winds steer African desert dust across the Atlantic Ocean towards North America, ESP, the Caribbean and Florida. The weaker the trade wind becomes, the more rainfall it brings. Trade winds are stronger in winter than summer. The one region of the Earth where trade winds are absent is the North Indian Ocean. These trade winds are the most regular of all the planetary winds. They blow with great force and in a constant direction. They were thus helpful to early traders who depended on the wind when sailing the high seas, hence the name trade winds. Since they blow from the cooler subtropical latitudes to the warmer tropics, they have great capacity for holding moisture. In their passage across the open oceans, they gather more moisture and bring heavy rainfall to the east coasts of continents within the tropics. As they are offshore on the west coast, these regions suffer from great aridity and form the trade wind hot deserts of the world, e.g. the Sahara, Kalahari, Atacama and Great Australian deserts. 2. Westerlies. Westerlies are the prevailing winds in the mid-latitudes, i.e. between 35 and 65 degrees latitude. The strongest winds are usually in the mid-latitudes, where cold air from the Arctic meets warm air from the tropics. They blow from high-pressure areas in the force latitudes towards the poles. Westerlies blow from the southwest in the northern hemisphere and from the northwest in the southern hemisphere. Westerlies are instrumental in carrying warm equatorial winds towards the western coasts of continents. They are responsible for carrying desert dust from the Gobi Desert into North America. They are stronger in winter than in summer, and over regions that have less land to interrupt their flow. They are stronger in the southern hemisphere because of the vast ocean expanses uninterrupted by land mass. It must be pointed out that not all the western coasts of the temperate zone receive westerlies throughout the year. Some of them, like California, Iberia, central Chile, southern Africa, and southwestern Australia, receive westerlies only in winter. This is caused by the shifting of the wind belt of such regions, which lie approximately between the latitudes 30 degrees and 40 degrees N and S due to the Earth's inclination. The sun is overhead at midday in different parts of the Earth at different seasons. The entire system of pressure and wind belts follows the movement of the midday. In June, when the overhead sun is over the Tropic of Cancer, all the belts move about 5 to 10 degrees south of their average position. The Mediterranean parts of Europe and California then come under the influence of the westerlies and receive rain in December-winter in the northern hemisphere. From the subtropical high-pressure belts, winds blow towards the temperate low-pressure belts as the variable westerlies. Under the effect of a Coriolis force, they become the southwesterlies in the northern hemisphere and the northwesterlies in the southern hemisphere. They are more variable in the northern hemisphere, but they play a valuable role in carrying warm equatorial waters and winds to western coasts of temperate lands. This warming effect and other local pressure differences have resulted in a very variable climate in the temperate zones, dominated by the movements of cyclones and anticyclones. In the southern hemisphere, where there is a large expanse of ocean, from 40 degrees S to 60 degrees S, westerlies blow with much greater force and regularity throughout the year. They bring much precipitation to the western coasts of continents. The weather is damp and cloudy and the seas are violent and stormy. It is thus usual for seafarers to refer to the westerlies as the roaring 40s, furious 50s and shrieking or stormy 60s, according to the varying degree of storminess in the latitudes in which they blow. 3. Polar easterlies. Polar easterlies are the prevailing winds which blow out from the polar high-pressure belt towards the temperate mid-latitude low-pressure belts. These are extremely cold and dry winds as they come from the tundra and ice-cap regions. They blow from high-pressure areas near the poles towards low-pressure areas within the mid-latitudes. They blow from the east to the west. Polar easterlies are often weak and irregular. They are more regular in the south than in the north. They are also called polar Hadley cells, named after George Hadley, who discovered them in 1753. B. Seasonal winds. 1. Monsoon winds. Monsoons are defined as seasonal reversal of winds accompanied by seasonal changes in precipitation. The major monsoon systems of the world are the West African and Asia-Australian monsoon systems. The origin of monsoons about 15 to 20 million years ago has been linked to the uplift of the Tibetan Plateau after the collision of India and Asia 50 million years ago. Cause of monsoons. In essence,
Okay, next time